Hello, this is Yathard from the Imaxer team, and this is our demo video for Imaxer, an AI image upscaler that we made using AWS Learners Lab. This is the landing page that we're greeted with. This, in itself, is an EC2 instance, a T3.micro EC2 instance that is publicly visible. To this, we upload any simple image that we want to upscale. Upon pressing this button, it sends a request to the backend at the /API/upscale endpoint, which will then delegate a worker resource, which will start the image processing. This takes a while, and we're done. We can now download the image and rename this something. Now, we are going to check the difference between these two images that we just. This is the original image. And this is the upscaled image. So the functionality definitely works. Now, let me walk you through the architecture of the same thing. What we did was we took a three-pronged approach. We had three different kinds of EC2 instances running, and the first one is the public-facing server. This is the only EC2 instance in the entire project that has a public IP address. This is a part of the project web security group, which only allows it to communicate with the backend, which is a separate EC2 instance. Now this does not have a public IP address, and even SSHing into it has to be done through the public-facing server. Alright, and this is what controls pretty much everything in this entire orchestration. More details will be given about this by Daksh in his section of the video. Now, this is connected to the load balancer, and the load balancer calls upon these different worker instances. These worker instances run the actual AI algorithms, which are CPU based, unfortunately, because we couldn't get a GPU instance running on AWS. So these run the actual image processing. How we implemented our load balancing is going to be apparent here. If more than two concurrent processes are occurring at the same time, we'll see a surge in the number of instances. Currently, we see three different instances: the public-facing web server, the backend, and the worker. The worker is what we made into an AMI image. As you would notice, it is also a larger instance type, because this runs the CPU model, which requires more compute. Now, if we add a lot of concurrent requests at the same time, we should be seeing a surge in the number of worker instances. All of these are starting to work. Now, we'll take a look at the number of instances that we have. As you can see, there is a new instance that is being initialized. This has been auto-scaled and has been put in place by the load balancer that we used. We also ended up making a dashboard, a custom dashboard that could show us what is happening. There are different metrics that we chose to keep track of. Some of them are pretty obvious, like the RDS utilization and the web server utilization and the NAT gateway throughput. These are a bit more architecture specific, as these are the worker instances that the load balancer spawns and the amount of CPU utilization that they have. We will respawn. Now, when we take a look at the instances, we can see that this is taking a while to load. Well, this is just how AWS works, I guess. Taking a look at our images, they've all been processed, and we have the upscale versions for all of them.
Hello everyone, I'm Zainab and this is IMAXer, our AI image upscaler. We have three parts to it, the front end, the back end and the dashboard. Let's start with the front end. It is the public facing Nginx page, kept deliberately minimal. We drop in a JPG or a PNG, we hit upload and it fires a post to the backend. That's all the public server can do, which is why it also acts as a DMZ. For the backend, it's run on a private subnet with no public IP. It is the conductor of the whole operation. It validates the file, pushes it to the S3, logs the job in RDS and hands the work off to the load balancer. The client never touches the S3 directly, and once the processing finishes, the download button appears and the upscaled image streams back through to the backend. Lastly, for the dashboard, it is a custom CloudWatch board tracking the CPU across every instance, NAT, throughput, RDS load, and the number of workers we've spun up, capped at 3. So this is how the workflow looks like. And once everything is done, the image is returned back through the backend to the user, and then the user can see a download button from where he can download the uploaded upscaled image. Thank you.
Hi, I'm Daksh, and I'll be presenting you with upscaling in IMAXer. So for the model, we are using the real ESR GAN model. This model is highly demanding and intensive, and is typically run on GPUs, which have significantly more processing power than CPUs. And since our AWS lab did not allow for GPU-based instances, I had to find workarounds for this. I adapted for this challenge and chose to run real ESR GAN on CPU. This led to worse performance, and we were unable to get an upscaled image back in time. I spent time optimizing, and I tweaked the model and parameters to ensure that the model performed the best it could on low-performing hardware, and we were able to maintain great performance while hitting our target image resolutions. To handle the heavy CPU processing, as a result of running a whole upscaler model on a CPU, we chose T3 medium workers as our worker instances, and they were load balanced using ALD. We configured our autoscaling such that if there were more than 2 concurrent processes, a new worker would be spawned automatically. A significant limitation that prevents us from deploying this at a larger scale was that our AWS environment only limited us to 3 additional workers. We could not deploy downscaling/deloading as ALBs only allow us to scale up. I was also responsible for coding the backend functionality and for configuring our EBS volumes. We made sure to back up the backend and our databases, but intentionally did not back up any worker instances since those are completely transient by design. This project presented me with some fun and interesting challenges, like getting the model to run on CPU only or figuring out load balancing, but it was a great learning experience and I'm proud of IMAXer in its current state. This would have not been possible without my team members. Thank you so much.
Mahi Patel, and I'll be presenting section 6, database integration using Amazon RDS. So for our project, we used Amazon RDS running MySQL to track the status of every image upscaling job. Our application works asynchronously, which means when a user uploads an image, they don't have to wait for the processing to finish. Instead, the image is processed in the background. Because of this, we needed a shared source of truth. So both our backend server and the worker instances can read and update the same job information. So we created a database called Upscaler DB with a table named jobs. So each row stores the job ID, current status, original file name, and S3 locations of the uploaded and processed images. As a job moves from queued to processing, then done or failed, the backend updates the database and the front end polls the database to check when the image is ready to download. So for security, the database is deployed in a private subnet with no public access. The security group only uses our backend EC2 instance to connect on port 3306. So from this task, I learned how Amazon RDS securely manages the application data and supports asynchronous applications by tracking background jobs. One challenge was securely connecting EC2 to RDS, which we solved by correctly configuring the DB subnet group and security group. Thank you.